Hi everyone. Today our agenda is again the data visualization. We are continuing with the same topic. This is data visualization. Today we are going to learn box plot. Now what is box plot? Box plot, it is the plot which is a type of descriptive diagram. Descriptive diagram means it will show some measures. From the diagram you're able to identify number of measures about the data series. It will give you the type of distribution the data set has. This helps to study the distribution of data. It is also called as 5-number summary. 5-number summary, it will give the measure of 5 values. That is, what is the minimum value, what is the minimum value, what is first quartile, what is second quartile, what is third quartile, and maximum value. And the other thing, it will provide outliers. So from the diagram, from the box plot, you are able to see what is minimum value. Minimum, which is the minimum value in the data series. What is the first quartile? Quartile, what do you understand by the quartile? Quartile means if you divide the whole data series into 4 equal parts, so the number which shows represent the first quartile, that is known as Q1. Second quartile is the median. Median is the middle value of your numbers. Third quartile, it is the 2/3 part, you can say 2/3, which represent number which is the third quartile, and the maximum value. It means you are dividing the whole series into 4 equal parts. So first is the minimum, Q1, Q2, Q3, and the maximum. So these are the 5-number summary that box plot gives us. And outliers are the numbers which does not lie in this particular pattern. It is out of range, extreme numbers. Okay, so median, the middle most value of a data set. It is also known as 50th percentile, a number which lies at the 50th percentile. First quartile, it is also known as 25th percentile. Third quartile, it is also known as 75th percentile. And what is interquartile range? Once you are able to find out the Q1, that is first quartile, and Q3, that is third quartile, the difference between them is known as interquartile range. In outliers, the values of the data set that differ significantly from the values present in the data set. These are basically the extreme values which does not lie in the range. That is called outliers. You have lower outliers, you have higher outliers also. Basically, this is a sample box plot. Your box plot will look like this. So this is a box plot. It will show a line between lines. This line shows the median and the minimum. Minimum is the minimum value, and max is the maximum value. This first one, minimum के बाद जो next line है, that is Q1, that is fourth quartile. Then median, after the third, after median there is a line called Q3, that is the third quartile, and then the maximum. Outliers are shown in circles, if any. Okay, I'll show you this as an example. This is the function box plot. We will use again matplot pyplot.boxplot. The name of the function is box plot. We'll use box plot just like for the bar graph we have used bar. For histogram we have used hist. For the box plot we will use box plot. And there are different parameters which we can specify. Notch, word, that I will discuss while doing hands-on. Mean line, show box, patch artist. These are the arguments which you can provide with this particular function box plot. So let us clear these terms. What is basically a quartile? If I take a set of numbers, data series, because before plotting the graph, I need to explain what are the various, how to find out these quartiles. So let me take an example for this. Let X These are the numbers which student has obtained in their test out of 10. This is 4, 6, 8, 9, 10, 10, 10, 3 and 4. This is our data set. Now we have to find out the quartiles and medians, outliers, maximum, minimum out of this data. So first step is to sort this data. Let me sort this data first. So now my X becomes, this is my sorted data. Let 1, 2, this 3, there is 2, 3, 4, 4. There are 2 4s in the data series. Then 6, 8, 9, 10 and 10 again. Now I need to find out. See, if I show on this line, if this is my minimum value, so what is my minimum value here? My minimum value is 1 here. So minimum value is 1. Another measure it is what is the maximum value. Maximum value, this is the minimum value. This is the maximum value 10. These are the two measures which are shown, minimum and maximum. Now the median. How to find out the median? Because this data set value 8, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. This is the 11 set of values. So my number of elements are 11. If number of elements are 11, then I can easily find out my n by 2th term is my median. So n by 2th term. What is n? N is 11. N plus 1, sorry. So in 11 plus 1 by 2th term. This is 12 by 2. This is 6th. So 6th term is your median. What is the 6th term? 1, 2, 3, 4, 5, 6. So this is your median. Now we have to find out the quartile. So this is the range in which we have to find out the quartile. 4th is the median, then we are left with 1, 2, 3, 4, 5. So in this range, we are able to find the quartile 1, Q1. Again, we will find out the median of these numbers. So it is 1, 2, 3, 3, 3, 5. Number of elements are 5. So 5 plus 1 by 2. So what is the median of this range? If you are able to understand what is the median, this is the median. Similarly, for this particular range, number of values are 5. So 1, 2, 3, 4, 5. In this set of 5 values, the middle value is 9. So this is your Q1, 4 is your Q2, and this is your Q3. So you are able to find minimum value, Q1, Q2 is your median, Q3, and this is the maximum. Is this clear? Because n is 11, so you are able to easily find out the values because this is odd numbers. What if it is even numbers, even set of values? Let X is now 1, 2, 3, 4, 4, 6, 8, 9, 10, and 10. Now here n is 10. How we can divide it into two parts now? So this is 5 set of values, this is another 5 set of values. How can you find out the median? In this case, we'll find out the median by taking the average of these two numbers. So in this particular case, if where the number of elements are even, I will find 4 plus 6 by 2. So 5 is my median. So median somewhere lies there. 5 is the median. If 5 is the median, So this is my quartile 2. Minimum is this, maximum is this 5 is the median. Now I want to find out Q1. Q1 is from this range of values, 1, 2, 3, 4, 5 values. So this 3 is a Q1. And again, in this set of values, if I find out this 9 is my Q3. So this is how we will find out the quartile 1, 2, 3. First we find out the median, and then in first left part we will find out Q1. In the another right part we'll find out quartile 3. I hope it must be clear now. So these 5 set of values will be shown in a box plot. Now we'll do some hands-on. This is the data set I have taken. Let us open Python. New file. I'll copy the code here. This is the data set we have considered, and we simply use the command boxplot L and then show. Run. So here, this is the diagram. In the given data set earlier, as I have shown on the whiteboard, this is the first set in which we have n is equal to 11. In this n is equal to 11, our quartile is 3, minimum is 1, quartile 2 is at 4, median is 4, and quartile 3 is 9, and then 10. So let us see here. This is the minimum value. This line shows the minimum value. This is 4. This is 4. This orange line shows 4. This is the median. And most of the values, then this is 9. 9 is quartile. This is quartile 1. 9 is quartile 3. And maximum value is 12 here, because in the data set I have taken 12. Let me, I have taken here 10, make it 10. So here the maximum value is 10. And it's the maximum value. So all the 5 measures, the minimum value, the median, this is the median, first quartile, and third quartile, and maximum. This is shown. Now there are the various parameters we can use with this. Various parameters that we have discussed in this slide. There is a value called show means. Show means equal to true. Show means equal to true. It will actually show you the mean value using this green. You see this green arrow? This will show you the mean value. If you find out sum of all the values, divide by the number of values, you will get the mean. So if you want to show the mean in your diagram, then you have to use this argument show means. Now we have notch. Notch equal to true. It means from the median, it will move inwards. It will narrowing the box from the median, and that particular graph will receive after notch equal to true. It is also known as notch plot instead of a box plot. See here, from the median, it is narrowing the box. So this is also known as notch plot. Another is, because by default the graph is vertical, if I make it false, then my graph will be horizontal. See here, I have received the horizontal graph. Again, this is minimum value. This will show the Q1, Q2, Q3, and the maximum. This is the horizontal graph we will obtain by making vertical falls. I will do this vertical falls, then I will just see the horizontal graph. There's one function called show box. If I do this false, then the box will not be shown. See here, there is no box here. It will not show the box. If you want to by default, it will show the box. If it doesn't want to show the box, then you can make it false. Another parameter is patch artist. Patch underscore artist. You have to make this function true if you want. True in the two T is capital, then only it makes a keyword. Run, and you are able to see the filled one. Patch artist, through patch artist, you can fill box with the color. Now, if I want to make it for two data sets, let L2 is another data set in which I have the different set of values. Let us take it. Control C, Control V, 5, 3, 4, 5, 6, 7, 8, 9, 10, 11 values. 11 values. Let's 8, 9. Let's change some of the values so that you can see, able to see the change. Now in the box plot, we will write L. Another is L2. This is multiple plots. Comma. I want text. L2. And you are able to see the two graphs. See, this is 1 and this is 2, the second one graph. Now, if you want to label it, you can label it also. You can proper provide labels. You can write your labels, and I can write here class 11. And another is class 12. So we have provided here the labels. Labels equal to. So this is class 11. This is for class 12, and you have got multiple plots in a graph. You can put more graphs here if you want. So we can add more data if you want. Now, one more thing that we need to explain after plotting this graph. Let me share the screen whiteboard. Let us in this. I wanted to show you two things. What are the outliers and what is the range? We are able to find out Q1, Q2. We are able to find out the median also. So let us take. We are able to find the minimum value, that is 1. We are able to find Q1, that is 3. Q2, we are able to find that is 4. Q3 is 9. And maximum value we have got is 10. So what is IQR? There is a term called IQR. IQR is interquartile range. IQR. IQR is this range. From Q1 to Q3, it is IQR. And IQR we are able to find Q3 minus Q1, and Q3 is 9, Q1 is 3, and this is my range. IQR is interquartile range. This is basically the measure of amount of spread in the middle. How much data is spreaded in the middle of the graph. This is called IQR. Another thing, what is outliers? Outliers, I told you earlier also, it is the set of values that lies outside the overall pattern. They are visualized as circles in the box plot. Okay, to find out the lower outliers, lower outliers which lies before Q1, which is less than Q1. Q1 is your first quantile, which is less than Q1, which is less than this, that is called lower outlier. We'll find out by the formula. There is a formula called Q1 minus 1.5 into 6. This is the formula for calculating the outliers. So it is 3 minus 1.5 into 6, and it comes out to be minus 6. For finding the higher outliers, there is a formula Q3 plus Q3. It is more than Q3. Higher outliers plus 1.5 into 6, and this comes out to be 9 plus 10 into 6. 5 3s are, 5 2s are, 2 3s are, 9 plus 9, 18. So any values which is less than this, any value which is greater than this, they are outliers. Now let us take these values in our pattern in the Python. We'll go to that Python code. We'll see this code. Here in, let us take one data set. Only one data set. L. So let's -7, and one value is let contain. So these are the two numbers which are lies on the extreme lines. These are outliers basically. So we'll run this. Can you see the outliers? This is the 18, and here this small circles denote the outliers. Outliers, this is the lowest. I have shown here, I have taken -7, and on the upper side I have taken 19. That is also outlier which does not lie between the interquartile range. So these are also we can identify through our box plot. So 5 measures. What are those measures? The minimum, the quartile 1, quartile 2, quartile 3, and then the maximum. And another thing we are able to find out from the box plot is the outliers, that is lower outliers and the higher outliers. Outliers are the data values that lies outside the overall pattern. They are visualized as circles in a box plot. So this is an exercise for you to do. Create a box plot from the following data. The data is given. You will simply provide the data in the Python. You will include the library, call the boxplot command. This graph is made for you. But one thing I wanted you to do in your notebook, that you will manually calculate the Q1, Q2, Q3 maximum and minimum, and then match with your graph. Is it matching with your graph? Another set of values is this one, and for this you will plot the horizontal box plot. What summarized that? So 2 of the box plots you will create, and second thing, in the practical file you will paste these diagrams, and you will also calculate Q1, Q2, Q3, the 5 measures manually also. So that's all for this particular class.